All right, here we go. So 5.8, question number 4. Population of a southern city follows the exponential law. As soon as you read that phrase on the next exam, oh, by the way, I put it on the board for you. The next exam is going to be as soon as we get back from spring break. No, I'm kidding. It's the week after, so we won't have to study over spring break. But that's the week after we get back from spring break. Well, you know what I mean. It's not the immediate week. So April 10th. So it's going to cover 5, 5, and 10, 4. Put the quiz on Thursday. All right, let's move ahead. So when you read the words exponential law in the exam in a few weeks, you're supposed to right away go, oh, okay, they mean PERT. That's the exponential. That's exponential growth. That's smooth, continuous exponential growth. Right? That's the one we use. We use PERT for this whole section, don't we? Because that's continuous, smooth growth. Remember the financial section? That was continuous growth. The other formula was, remember the other one, which is A, P, 1 plus R over N to the NT? That was for compounding that wasn't continuous. It was like monthly or yearly or weekly or daily or quarterly or whatever. But we're talking about things that are growing smoothly, continuous compounding. They're all about the PERT. Okay, here we go. Population doubled over 14 months. The population doubled over 14 months. How do I do that? 2p. Yeah, good. The amount becomes 2p. We've done that before with financial problems, right? How long till you double your money? 2 times the principal. And that takes 14 months. So put in t is 14 and amount is 2p. We good so far? Now, phase 1 on these PERT problems, phase 1 is find e to the r. I know on that quiz one I just showed you, we actually found r. That's because they made me do it that way, and they had multiple choice answers that had to show the r. But if they don't force me to do that, it's going to be easier to, if I'm just doing it on my own, it's going to be easier to find e to the r. Is that making sense? That's really important that you know on these PERT problems that phase 1 is finding e to the r. All right, let's do that. So everybody see what I did. Double, amount is double. Plugged in, r is 14. All right, go ahead. Rather than me whipping it out, I think you'll get more out of it if you do the next couple steps. Find the e to the r. Can you do that? Some math steps, give you a chance. Feel free to chuckle those around you. I think you would benefit by more talking with your neighbors during these times. You know, try to get as much as you can out of these 2 hours we have twice a week. Talk with your neighbors, compare and contrast, see what you're doing right and wrong. Help each other out. Let me know if I can help, if I wander around and help. Well, you know what? Too many of us in here, I can be helpful.
We say round to the nearest one.
Right.
So find e to the r. So, okay, that's r. That's r. That's not e to the r. So find e to the r. So isolate e to the r. So the plan is to get this alone, not r. Not r, so I'm not going to do ln. All right, what's the first step? Divide by the p, right? Just divide by the p by p. Bring it up here. 2 equals e to the r times 14. Good so far? Now, remember what we're trying to do. We want e to the r. This will be easier. This is the easier way. I know Math Excel doesn't show it this way, but this will be easier. So we want e. We want this part alone. I don't want r. That's why I'm not going to do ln. Because if I did ln, that would bring the r down. I don't want r to come down. Look how I want it. I want it what? Still up. I still want to leave Hitler in power. I want to leave the letter up there in power, don't I? I don't want to bring it down. Everybody see my goal? See the target I'm aiming the arrow at? This is what I'm aiming at. I want to leave r in power, so I'm not going to do ln. Well, you did that a minute ago on this quiz question. Yeah, because I had to find r on this quiz question. Because why? Because all their answers had r isolated. So I had to do ln because I had to get r out of power to find out what r alone is. See the difference? The multiple choice, they gave me multiple choice answers that had r showing. So I had to come up with r itself. But normally they won't do that. Normally they'll just say, hey, do whatever you want. Just solve the problem, like this one. Right? Just give me the final answer. How many people? So then I'm just going to get e to the r. So how do you do it then? If you don't do ln, because you don't want r to come down, well, how do you get rid of that 14? That's really the question, huh? If I get rid of that 14, I'll have e to the r. How do you get rid of that 14? What do we do? Yeah, 14 root or 1/14th power, same thing. Either way, that'll do it. 14th root or 1/14th power, same thing. That'll get rid of just the. Everybody see why am I doing that and not ln? Because I just want rid of the number, not the r. I don't want the r to come down. I just want rid of the number, huh? So 2 to the 1/14th power is e to the r. Got my hands on e to the r. Everybody good there? See how I found e to the r? Now, how does that help me? What does that do for me? Well, let's go back to the PERT. That's our original formula. Now you know what e to the r is. It's 2 to right here. E to the r is 2 to the 1/14. To the t. Everybody see that? E to the r is 2 to the 1/14. So in the e to the r slot, I put 2 to the 1/14. T still up there. Is that okay?
I don't understand why is the T still there?
There's a t here. So I just replaced this part. I just replaced e to the r. E to the r is 2 to the
But
1/14.
isn't 14 the T?
Well, yeah, I plugged in 14, but that's over now. Right? So no, track with me. I plugged in 14 for t. Sure enough, I did. I plugged in 14 for t. Right? Then I got to here. So here, let me show you the So I plugged in the 14. I got to here. Now look at what this says. Look really close at what that says. That says any place you see e to the r only, you are free to replace it with 2 to the 1/14. Isn't that what that says? So where I see e to the r right here with the t off to the right and the p off to the left, right there, that I replace with 2 to the 1/14. That makes sense? See what this equality is telling me I can swap out, swap in? Does that make sense? And having done that, that t on the outside, it's just going to multiply that power, huh? So, and since it's t over 1, might as well just stick it on the top. It's just going to end up being t over 14, isn't it? That'd be a little easier to deal with. Is that okay? Just make it t over 14, same thing.
They end up giving you t.
They end up giving you t. Yeah, I'm going to plug in t in a minute, but I need this formula first. Is that good? Does everybody see what it does? I just put that. Is that okay? I put that t in there because it's just t over 1 is just going to multiply and be t over 14. Yeah, now this formula, I can answer any question. So that's the most important part. Phase 1, get to that formula. And what I mean that formula? Well, now I've got A and T. I can answer any question they want to ask me. Oh, I forgot about current population is 40,000. What do I do with that? Where does that go? That's the P. That's the original population. That's the now population. That's like the original investment. Here, let me get a fresh screen on this thing. So A equals P. 2 to the t over 14. And the p is the 40,000. Because remember that p is the original investment, the current amount of people. 40,000. 2 to the t over 14. Like that. Good? So now we have the formula by which we can answer any question they want to ask us. And what's their question? 5 years from now. How many people? So 40,000 now. What are we even talking about here? So population of a southern city. 40,000 live in the city now. How many 5 years from now? Fresno's growing, isn't it? I was thinking about that on the way to work today. There's a whole bunch of new houses going in around where I'm at. How much in 5 years? I don't know. It's growing. So 40,000 is now. That's the original principal, the original amount. How much in 5 years? So what do I do with that 5? Or what do I do? That's time. That's time, huh? Do I just plug in 5 right here for t? Why not? Good job, Erica. Months. Remember, you got to be consistent with whatever your time units are. You can't change your mind. So we used months originally when we solved things. So we have to be consistent with that. Does that make sense? You can't change your time plan. So you could do it all in years, or you could do it all in months, but you can't change halfway through. So since we started with months, I have to continue with months. So 5 years times 12 months in every year is 60 months. So it's 60 that I'm going to plug in right there for t. Question, comment?
Oh, no, you answered
That good? All right. So then it's 40,000 times 2 to the 60 over 14. Hit the buttons on your calculator. And I'm getting 780,168.7. I think they say round to the whole number, so 780,169. Thank you.
Would I be able to do that one? This kind of calculation?
Carissa. I'm sorry, I called you Erica.
Oh, it's a.
Yeah, I think you can do it on that. That's a rough calculator.
How would I do a, I guess I wouldn't be able to do a power.
Yeah, they have the X to the Y button on, I think.
Oh, yeah, they do.
Yeah. You guys getting that? Are you okay with getting that answer? I want to help with that. You guys have your calculator? Try that. Erica. Yeah, one thing that's important, remember the main lesson with using a calculator is if there's more than one item in a zone, you got to parenthesize it, right? In this case, there's a 60 over 14, two things in the power zone. That means you have to parenthesize those when you type it into your calculator. In other words, you got to put, what am I doing here? Here we go. We've got to put parentheses around that power. In other words, you got to type it in like this. For here, bring it up here. Here's the calculator step. 40,000 times 2 to the power, parenthesis, 60 divided by 14, parenthesis. Everybody see that? That's what you have to type in. You have to put parentheses around the 60 divided by 14. Why? If you don't, it'll just take, if you just type 2 to the 60 divided by 14 like that with no parentheses, it'll just go 2 to the 60 and divide the whole thing by 14. It won't know the 14's part of the power action. It'll just think the 14's afterwards. It only does the immediate first thing in the power unless you put parentheses. So you always have to remember, if more than one thing in the numerator, denominator, or power zone, parenthesize it. Coming out now, okay? Everybody getting that number? Look what that city did. It went from 40,000 to almost 800,000 in 5 years. That's fast growth. That's like LA, Southern City, right? Silicon Valley did that, yeah. Exponential growth. Is that good? It's not good. Yeah, it's getting. Isn't it getting worse? It's slowly getting worse, isn't it? And all these more houses coming in. It's not getting better. Oh, is there a big thing down Clovis South coming in? Okay, I'm not keeping up. Okay.
So they're all going to use 180, and you got 168. It's all going to bottleneck.
Yeah. That's right. You got to move to Indiana. No, Idaho is. Why is everybody moving to Idaho? But a lot of people are going from California to Idaho. That's like the thing to do, isn't it?
People from LA come here.
All right. The half-life of radium, 1690 years, 50 grams present now. How much in 160 years? So, all right, what does half-life mean? The half-life of a chemical. Now, what's the half-life? How long till there's only half left? Yeah. So if I said, hey, I've got this, I got some Play-Doh, right? I've had Play-Doh sitting on my counters in my house. You know, a big blunk of Play-Doh. I just asked my wife today. Do you know what I have in my counter? Those little sponge things that expand in water. Have you seen those? Those things. And I don't know why my kids still, my littlest two, still want to play with those. You know, they're 14 and 11 now, I think. Isn't that over?
At least they're not doing the slime.
Over.
Slime.
No, they do some slime stuff too. My wife, she's nicer than me. She puts up with all that. And I remember to ask her just last week, honey, can we just put an end to the... Because it'll sit on my kitchen counter for like a week. It'll growing. What is it here? Can we be done with that phase of our life now? This is over, right? Kids are old enough. Anyway, so if I put the big chunk of Play-Doh, 100 grams, and say it goes down to 50 grams in a year, just on its own, just kind of goes into the environment of our house. So it shrinks. So that'd be a half-life of 1 year. In 1 year, it's half of what it was. So it goes from 100 grams to 50 grams in 1 year. Then, one more year, it'll go down to what? 25. So it won't go to 0, right? It's half of it goes away. So 100 to 50 to 25, so, every year, half of it goes. That's what half-life means. How long for half of it to go away? No matter how much you have, half of it will go away in whatever they say the half-life is. So this one takes a little longer. 1,690 years, half of this radium will go away. If you leave it out, it'll just go into the environment. Okay. Formula we're going to use? PERT, of course, always. PERT formula. Basically, this is decay. They call this growth, like that southern city was growing, and now this is decay, going away, shrinking. It's not what's happening in California. So growth and decay. For the decay problems, the R is going to turn out negative. That's going to cause the shrinking, the decay. All right, so here we go. The half-life is 1690. That means when T is 1690, put in 1690 for T. What is the A going to be? Remember the doubling problems we did back in the financial? How long till your money doubles? What did we put in for A on the doubling problems? 2p. So now we're saying how long till it's half? So what are we going to put in for A? It's not double, it's half. Instead of 2p, it's half p, or decimal would be nice. How about 0.5p? Make sense? So it's just like doubling, 2p, but instead it's half p, 0.5p. Does that make sense for half-life? It's half of p. It's half of the original amount. P is the original amount, original principal, original radium, right? So now the amount has become half of the original after when T hits 1690 years. Okay, so what is phase 1 all about again? What are we always doing in phase 1 on PERT? Finding e to the r. E to the r. So I got to solve. This e to the r is saying, get me alone. Get me alone. Get rid of the p. Get rid of that 1690 so that I can be alone. The e to the r can be alone. Can you do that? So go ahead and do the steps necessary to get that e to the r alone. And then see, I bet you can finish this one. Then see if you can go on and finish that problem. I'll give you a minute. Wander around a little bit. Check with those around you. Free to talk it out with people around you if you need to. Want to?
You guys see it? 0.5.
But it's still 0.5 times P though, so it still would be able to nullify the P, right?
Yeah, you just realize
0.5 equals E to the R.
Write out that P first off, huh? Like that. Good. And then here's the e to the r. Keep kind of aiming at the target. E to the r is your target. E to the r is saying, I want to be alone. So what do you do to get that e to the r alone? Gotta get rid of that 1690, huh? What's going to get rid of that 1690? 1 over 1690, yeah. Both sides 1 over 1690, right? We're not going to do ln. Why am I not doing ln? Because that'll make the r come down. I don't want the r to come down. Is everybody seeing that? Right? Because my goal is to leave the r up, not come down. So I'm not going to do ln. That would bring everything down. I want to leave Hitler in power. So instead I'm going to do 1 over 1690. Boom. All right, so what do we get? 0.5 to the 1 over 1690 is e to the r. Good? Is that making sense? See how these canceled here? Got e to the r alone? Are we good? Are we not good? Questions I can answer? Now, what do? You rewrite the PERT. Rewrite the PERT. But now, in the e to the r, we replace just the e to the r with 0.5 to the 1 over 1690. Everybody seeing that? That's what this equation is saying. It's saying wherever you see e to the r, you're allowed to replace it with 0.5 to the 1 over 1690. So that means all of this goes right there, doesn't it? You're good? Good. So do that, and then finish their question. What's their question? How much in 160 years? So once you get that, plug in 160 on that. Give you just... Okay, so we plug in. So where we see e to the r, we replace it with that 0.5 to the 1 over 1690. Is that making sense? So 0.5 to the 1 over 1690 t.
You just plug these in. That's what we did.
Is that okay so far? Everybody seeing that step? That direct replacement, you know? E to the r becomes that. And you know this t is just going to go to the top, isn't it? Because t over 1. So you can just make this t and that'll be a little cleaner, like that. Is that good? Like that. Just put that t at the top there. And now we're ready to answer whatever question they have for us. What is their actual question? It is, how much in 160 years? So plug in, boom, right there, 160. So A is P, 0.5 to the 160 over 1690. Like that. And hit the buttons on the calculator, right? And,
46.
I forgot the 50. 50 grams are present now. So that goes in the P, huh? Yeah, I forgot about that. So put that right here. So the 50 goes right there. 50. Okay. Now hit the buttons on the calculator.
46.
4682?
Yeah.
What is he rounding there's thousands? So one more. 82.
41738.
So let's go 824. You guys getting 46.824? There it is. So it shrunk. Huh? It was 50. Now shrunk to 46. Not much, but that was 160. It takes a long time for that stuff to shrink.
Yeah, thanks. Yeah.
Isn't it half-life that shows you how radioactive something is?
Thanks. What's that?
Isn't it the half-life that shows you how radioactive something is?
I don't know.
The shorter the half-life, the more radioactive it is?
I don't know. You can tell me anything. I don't remember. I took Chem 1A, 1B, and completely forgot it all. Erica.
Right, so
Right, so the R is
Is it all-
negative.
Yeah,
Yeah, we never got R alone, so we never saw that. Yeah, we said never actually, I just got E to the R, we never got R alone, but it would be
What's your
negative.
major?
Yeah.
Oh, yeah.
Is that good? Questions on that? Now, having done this problem, they're going to give you like 3 or 4 in a row that are half-life problems. Let me give you a shortcut for doing half-life problems. Here's what I mean. Whenever you do a half-life problem, see how the formula right here became this? I'll give you a shortcut that'll jump you right to here, which is super nice because then you're only like 2 steps from the answer. Every half-life problem will end up with this 0.5, that's the half. And the 1690, that's the half-life. You can just jump right to there. So in other words, let me say it more cleaner. Half-life, if they give you a half-life problem, here's all, you can basically skip most of the work, step 1, and just go look. It's going to be P 0.5, because that's your half, to the T over whatever they tell you is the half-life. It'll always be that. So in other words, you could just go look. It's A equals P 0.5 to the T over 1690. 1690, which is what we ended up getting after a bunch of work. And then you could just plug in the last 160 and be done. Do you see that? That'd be a good thing to put on your 3x5 card. Half-life problems will always be the 0.5, that's your half, to the T over the half-life. It'll always be that one. That's just for direct half-life problems, right? They can be more tricky than that. They, like the other problems we did, right? They weren't all half-life, were they? Right. So I remember my 2 daughters took Mr. Jameson for pre-calculus here about a year ago, and they were in this section. I was helping him at the kitchen table. I still remember, And I said, girls, here, let's just save some time. Just use this half-life formula. I just gave them this quick little half-life formula. And I remember Lizzie saying to me, Dad, is that always going to work? Maybe you should show us all the steps for getting there. And all the ones that were in the homework were all half-life. I'm like, oh, no, that'll be fine. Mr. Jameson's not going to do it. Just use these. She's like, sure, Dad, you sure? Well, you don't want to show us the other? And I was late. And I was like, no. Just use that. It'll all be good. They took the test the next day. Mr. Jameson threw him a curveball. And it wasn't a half-life problem. Lizzie was furious with me. Dad, I asked you for that formula. And you did. Anyway, so I'm being clear now. So if it's a half-life problem, this will work. If it's any other kind of, you got to do the whole PERT thing. Right? If it's not a half-life. All right. So halfway through. At least halfway through. All right. Half-life of carbon-14, 5,600 years. So as soon as you see half-life, you go, okay, I got this. It's whoops, I forgot the P, huh? It's P 0.5 to the T over 5,600. We're already there, huh? Because there's the half-life. So we know that much for sure on a half-life problem. So now, take it from there. A piece of charcoal made from the wood of a tree shows 67% of carbon-14 expected in living matter. When did the tree die? Okay. 67%. They're basically saying 67% is left. 67% of the carbon-14 is left. So what are you going to do with that? Well, what if I told you, hey, the bank account is now double what it started? What would you put in for A? 2P, right? What if I said, hey, the bank account is now half what it started? I'm losing money. What would you put in for A? 0.5P. So now if I'm saying, hey, the bank account is 67% of what it used to be, what am I going to put in for A? 0.67P. Don't forget the P, right? Yeah, that just means plug in 0.67P. 0.67P. Yes, a lot of people forget the P. So I've seen over the years. So yeah, let me really help. Yeah, don't forget the P. I've seen that mistake by lots of students over lots of years. Watch out. And the reason it really messes you up, because if you forget the P, then you're kind of like stuck. And you're like, uh-oh, I can't get rid of the other P. So don't forget the P, because that way, you can get rid of the P right away from both sides, right? Maybe this will help. Would it make any sense if I said to you guys, hey guys and gals, 67%? You'd go, 67% of what? Right. You got to have something with it, huh? There's no such thing as a percentage alone, right? 67% of P, of the original principle, right? If that helps. You got to have that P there. It makes no sense, does it? All right. So can you solve that for T now? So go ahead. Let me give you a minute on that. Solve for T now. So divide by P on both sides, boom, boom. P is gone. Okay, let me help. So, there's T up there. So, yeah, that's the question. What are we trying to solve for? Time. We know what time, right? So, there's T. Where's T? In power. We want him out of power, don't we? This time we want the T to come down, because we are trying, right? It's not like the other ones where we want to leave E, those other ones where we're trying to find E to the R, and we want to leave the R in power, so we didn't bring it down with Ln. This time we're bringing it down with Ln, aren't we? So Ln, both sides, right? Because you want the T to come down. You're trying to solve for them. So the whole power drops down. And what do we get? We get T over 5600 ln 0.5. The other side ln 0.67. We good so far? To there, so we got it out of power, right? ln brings the power down. So we're still trying to solve for t. So let's go ahead and divide by the ln 0.5 on both sides. Boom. So we get T over 5600. Is it good so far? How do we solve for t now? Multiply by the 5600 on both sides. Boom. There we go. So whatever that your calculator tells you there. I'm getting 3235. 3235. It's 0.4. They tell you to round to the nearest whole number, so there we go. 3235. Y'all able to get that? 3235? Do you understand what that means? That's how they do carbon dating, what we just did right there. So in other words, the way it works is, again, I'm no chemist, I don't remember any chemistry, but I remember this much. There's two kinds of carbon. There's carbon-14 in living things, trees, insects, people, all this carbon-14, and then another kind of carbon. And when something dies, the carbon-14 begins to decay, starts to break down. As soon as a tree dies, or an insect dies, or a person dies, the carbon-14 begins to break down. The other kind of carbon, I don't remember what it is, stays put, doesn't decay, at least not that fast. And so that way, when they find something that has died, like a tree, they can compare the two kinds of carbon. They can find out how much the one has grown, because they were originally the same. And now at the point of death, the carbon-14 begins to break down. So they can say, oh, the carbon-14, look, compared to how much the other carbon is, it's broken down to 67% of what it was. And then they know the half-life of carbon-14 is 5,600 years, which is pretty slow. So that way it's like a time clock. Based on how much the carbon-14 has broken down, they can figure out how many years since the thing died. That's how they do carbon dating. That's how they find out how old something is based upon the point of death. Does that make sense on that? How that works? Questions on that problem? We good? So for half-life problems, just jump right to this formula. Put that in your 3x5 card for half-life problems. Okay. In case you have a pool, you're going to need to know this kind of math. I'm just kidding. It's about chlorine. I've got a pool. I just dump in chlorine until it looks blue. That's about all the math I do. I look out, it's not looking so blue. I put chlorine and acid in there. Anyway, so under certain weather conditions, free chlorine, swimming pool, decompose according to the law of uninhibited decay. After shocking a pool, the pool boy Jeff tested the water, found the amount of chlorine to be 2.9. So a lot of words. Here's what we need. It was at 2.9. That's how much the chlorine was. 24 hours later, it was down to 2.6. So it was at 2.9. 24 hours later, 2.6. Stop right there. That's enough information to find the rate. Do you feel that a little bit in your gut? What if I said, for example, if you know 2 points in time and how much time, well, that wasn't very well said. If you know 2 different points and how much time went between them, you know how fast things are changing. For example, if I said, hey, I went from here to LA, 250 miles, in 4 hours. You can calculate my average speed, right? I traveled 250 miles divided by 4 hours. I went average a little over 60 miles an hour. Right? So if you know 2 numbers and the time between them, that allows you to calculate rate, how fast things move between those two, right? Well, that's what we have here. The pool, the chlorine in the pool started at 2.9. 24 hours later, it was down to 2.6. You know how fast that stuff's breaking down. That chlorine's breaking down to the pool, decaying, decomposing. So, So what I mean is I'm just going to stop there. The rest of the stuff, like the 3 days and the other stuff, later. That's later. All I need is the 2 points in time and the amount of time between them to do phase 1. So the equation we're using is PERT, and phase 1, as you know, is find what? What are we trying to find in phase 1? Is this a half-life problem? No half-life here, right? No half-life. Can't use that little shortcut. So what am I trying to find then when I use the PERT formula? What do you find in phase 1 if it's a normal one, not a half-life? E to the R. E to the R. Is that good? Want to find e to the R? So let's do it. Just use the 2.9, the 2.6, and the 24 hours later. Once you've got that, the other questions will be a snap. That's the major work. So let me give you a little bit of time on that. I'm going to wander around, try to be helpful. So, and the 2.6 is the A. And the time is 24 hours. Everybody seeing that for the first step? Right? The P, what goes right next to the E? The P is the starting amount. When they told me it started at 2.9. Later the amount became 2.6. 24 hours later, time 24. Good so far? So let me do the next step with you because it's actually a little tricky. What do we do next to, we're trying to find e to the r, like always, huh? So divide by the 2.9, right? But when you do that, when you divide this on your calculator, it's really ugly, isn't it? If it's an unending decimal, well, a decimal that goes forever, a forever decimal, leave as a fraction. I don't want a decimal going forever because I'd have to round that. And see how they say do not round until the final answer? Because it'll really throw your answer off because this is going to end up being in the power zone eventually, and any rounding now will really make a drastic difference in the answer. So here's what's easier to do. If this came out clean, if I divided this on my calculator and it was something nice like 2.3 or something, then great, yeah, I'll just use that. But if it's a decimal that ends. But if it's a decimal that goes forever, then I'm just going to stay with the fraction for now. Okay, so where are we at? We've got 2.6 over 2.9 equals e to the r 24. So far, so good. Now, what am I trying to solve for? This part. E to the r wants to be alone. So I'm going to leave r in power. I'm not getting Hitler out of power. I'm going to leave him in power. Leave r up there. So what are we going to do to e to the r alone? 1/24 both sides, right? Is that good? So go ahead and do the 1/24 thing. Not making sense. So we'll say, okay, 1/24 this side, and boom, those cancel, don't they? So what does that give us? That gives us 2.6 over 2.9 to the 1/24 e to the r. So we got e to the r alone. No rounding, no decimals, it's exact. Good? So as soon as we get that, then we go, okay, we got our PERT formula. Now we can write PERT. A equals PERT. The e to the r is all of this stuff. So A equals P 2.6 over 2.9 to the T over 24, isn't it? Everybody okay with that? The e to the r is 2.6 over 2.9 to the 1/24. The T out there just goes to the top. It's getting comfortable. Questions I can answer to there. So now we can go on and answer the other two questions. It'll be easy, and I will do it. But I want to make sure we're good to hear. This is the hard part, the most important part. Does everybody see what happened there? Questions? See how the e to the r is replaced with the 2.6 over 2.9 to the 1/24? And then the t goes on the top? Okay, so now that we have that formula, this formula here, whoops, we'll use it. So I'll go to fresh screen if you got that down. So A equals P. A equals P. What was it? 2.6 over 2.9. T over 24, right? Yeah. Oh, we know the P, don't we? What's the P? P's the initial amount. What's that? 2.9. Remember, 2.9 was the starting amount of chlorine. So we can put that in also. That's the P. The start, right? Get that? It started at 2.9. 24 hours later it became 2.6. So the P is 2.9. It's the starting amount. And this is the E to the R. There's our T. All right, so now we can answer the questions. What are the questions? What will be the reading after 3 days? So that chlorine started at 2.9. After 1 day it was down to 2.6. How much is it going to be down to after 3 days? That's what they're asking. So keep breaking down. Right? We're expecting some number lower than 2.6. So keep breaking down. So how do we figure that out? Yeah, could we plug 3 in for T?
No.
Because now we're in hours, huh? We started with using the 24 hours, and so we got to keep using hours. That's why they're being nice to us and giving us the 72 as a big hint. 72 over 24, which is 3, and then hit the buttons on your calculator. I'm getting 2.089. I think they want you around to the 100th. So 2.09. Get around to. No. Yeah, because you might think, well, yeah. Can't we just cancel these 2 9s? Can we do that, guys and gals? Can we just cancel these 2.9s? This 2.9 is raised to the 3rd power. He's not. So we can't, right? So guys, just leave it as it is. 2.09? Good question. And then the second part, so we got that part. And then the second part says, when's it going to reach 1.0? So if they just leave it go, when's it going to reach 1.0? Make A1. Yeah, so we just restart again. We say, okay, same formula, huh? 2.9, 2.6 over 2.9 to the T over 24. This time make a 1. 1.0. Exactly. Clean it up a little bit here. Yeah, just make a 1. 1.0, 2.9, 2.6 over 2.9 to the T over 24. All right. What do we do to, can you solve that for T? This is T over 24 here. Can we solve for T? What do we do there to solve for T? What's the first step? T saying it won't be alone. Yeah, we're going to have to L in a minute, right? Divide by the 2.9. Again, this is an ugly decimal. If you go 1 over 2.9, it'll be some decimal that goes forever. So I'm just going to leave it. Remember how I just leave those? Are we good to there? So I divided by 2.9 on both sides. I'm just going to leave this because this is some ugly decimal. I don't want to round in the middle of the problem. Keep going. Now, I am going to L in here, aren't I? Why now? Because I do want Hitler out of power this time. I want that T out of power because I'm trying to solve for just T. Right? So yes, L in is what will do that. L in both sides. The power drops down. Power drops down. I'm going to go to a fresh screen there, Ellen. This problem going on forever and ever and ever. It's a long one. Ellen, what is it? Ln 1 over 2.9 equals Ln. What is it? 2.6 over 2.9. And then the power comes down. T over 24, that's a T there. T looks like a plus sign. We get to there. All right, how do we finish solving for T? I'm just going to take it in 2 steps. I'm going to divide by the ln of... No, that 2.6 over 2 needs to stay inside an ln, huh? Like that. Bonk. All right, we good. Coming up here. So now we have ln of 1 over 2.9 over ln of 2.6 over 2.9 is T over 24. Last step to get T alone. Multiply by 24. We okay? Hit the buttons. That's a tough one. Hit those buttons on your calculator. I'm getting 234. 234. T is 234. What is that? What is that 234? You guys getting that answer first off? 234? What is that? 200. My old physics teacher, if you gave an answer like 234, he'd say, "What is that 234?" You know, he always wants units. What is that? Is that he would always say, "Is that dogs, Heron?" If I give an answer like 2, say, "Heron, is that dogs? 234 dogs in the kennel?" What is that 234? Hours. It's time. It's hours, huh? Hours. So I don't know if they ask. Do they ask for hours on this part, or they want days?
They want hours.
They want hours. Great. I'm happy then. Is that okay? How was that? Are you okay with these? So they're not easy, are they? Questions I can answer? All right. All right, number 8. Remember how we talked about the other formulas? The PERT formula is uninhibited growth. Did we talk about that? We talked about the bunnies taking over an island. There's actually something called Bunny Island my other class told me. I did it in Google. Somebody did front row. Something called Bunny Island where the bunnies took over the island. I guess it still exists. It's off the coast of Percy's hand. Where is it? Japan. Japan, that's right. Oh, so you know. Yeah. Okay. Yeah. So anyway, uninhibited growth, right? So if you have any kind of living thing that has plenty of space, plenty of food, and no predator, it'll grow according to PERT. It'll just go crazy, right? Or LA, either one. It just grows like crazy. So, but in reality, you have predators. You have limited space and limited food, and things don't grow like PERT most of the time, other than Bunny Island, right? So how do you make up a formula to model? Remember, math is just made up. Math is simply made up to fit things that are real. So what formula do they make up when you have something growing, some bacterium or rabbits or whatever, and there are predators and there is limited space and food? Well, there it is. It's called the logistic growth model. That's what biologists use. It's more realistic. It's not unlimited. It's not uninhibited, it's got limits to it. So there it is. There's the look of a logistic growth model. It's a more realistic biological growth formula when there are predators and limits on food and space. All right, carrying capacity. What is that? That's the limit on space and food. It's how much it can carry. Right? How much can the space carry? How many rabbits can live on this island and have enough food and have enough space so that they don't all, half of them aren't starving because there's too many rabbits and not enough space and food? That is always the number on the top. That's all I want you to know. So you can put that on your 3x5 card. If they give you what's called the logic, if I give you a question, I probably won't. This isn't, you can tell by my tone, this isn't probably one of the things that's going to be on the exam. But I guess it could be. It might. I don't exactly remember. It might be, but I doubt it. But if I say, hey, here's a logistic growth model, tell me the carrying capacity. It's just that number on the top. So in a logistic growth model, the number on the top is the limit to the space for the critters. Next, what's the growth rate? So this is just like show and tell. I'm just pointing out different parts of it. What is the growth rate? Well, the rate is always right here next to t. No big surprise there, just like normal. Right? E to the RT, the ERT, that's the same thing. So the R is 0.333. And then you go 2 decimal places to make it a percentage, 33.3%. It's negative because it's shrinking, but we don't care. Okay, let's keep going. Initial size of the population. So those two are just pick them off. The top number is carrying capacity. Whatever's next to T is the R. The growth rate, meaning 33.3, it's changing by 1/3 of its population every whatever hour. So now, determine the initial population size. That's not as obvious as it is in the PERT formula. With the logistic growth model, it's a little harder to see the initial population. Anybody have an idea?
One.
It's not the one. What could I plug in? It's not something you can just grab. It's not any of those numbers right there. It's something you got to calculate. What could I plug in? If in any science problem, chemistry, physics, whatever, somebody says, hey, I want to know the initial, biology, anatomy, I want to know the initial. What do you plug in for time? 0. Initial means when time is 0, doesn't it? In any science formula. Whenever they say initial, they mean plug in T0. Is that making sense? On the PERT formula, let me show you how that works on the PERT formula. If you plug in 0 right here for the T in the PERT formula, that's e to the 0. 0 times r is just 0. P e to the 0. And what is e to the 0? 1. See, that's why it's just P. Do you see why the P is the initial amount in the PERT formula? But we're not dealing with the PERT formula now. We're dealing with this logistic growth model. So how do you find initial? Got to plug in 0 for T and work it out. This one requires a little more work. It's not quite so obvious. So take that thing and plug in T is 0. So it's going to be 9,000 over 1 plus 31.46 e to the 0. Is that okay? You plug in T0. 0 times 0.333 is just 0. And so that's what? 9,000 over 1 plus 31.46, isn't it? Because e to the 0 is just 1. Anything to the 0 power is 1. So that's just 9,000 over 32.46, right? 31 plus 1 is 32. Hit the buttons on your calculator. 277, I guess, because I'm looking at the answer right there. There must have been 277 grams of that bacterium initially, at the start, at T0. That's how they got it. Is that okay? See what I did there? So any science formula, biology, chemistry, physics, anatomy, whatever, initial means time 0. And then come on down here. When will the right here, part D, what is the population after 5 hours? So what am I going to do for 5 hours? Plug in T equals 5 and hit the buttons on your calculator. I'm going to move on with this section now, if you're okay. The rest are the same. I mean, they're not easy. E's a little challenging. It's hard to solve that formula. I'd be glad to help you. Come to office hours. Come see Tim. Hope you're taking advantage of the extra credit, going in there doing your homework in the tutoring center. That's almost half a grade in the end, 4%. If you put in whatever it is. What did I say? How many hours maximum? 30? Yeah, 30 hours. Yeah, hope you're doing your homework over there and you're getting your time put in there. Ask them about this one. Come see me. Be glad to help, but I better move on at this point. I'm going to leave 9 and 10.